Okay. Good night, guys. Welcome to class. Today we're going to be talking about elastic and inelastic collisions. So first of all, take attendance really quickly, and then we'll move on to explaining those two. So first of all, we have Carlos.
Present.
Okay. Patricia.
Present.
Okay. Everyone's here. Okay. Let's start with the class. So I want to talk a little about elastic and inelastic collisions, right? So do any of you know what elastic and inelastic collisions are?
No, mister, no.
Okay, so elastic collisions are basically collisions where the momentum and the kinetic energy are conserved. That means that you're going to have the same momentum and energy before and after the collision. Inelastic collisions are collisions where the momentum is conserved, however, the kinetic energy is lost. But that kinetic energy is not really lost, just it is changed into some other type of energy. So, for example, when two cars crash, some of the energy, of the kinetic energy of the collision is lost as sound or as heat. And that can be seen as a loss of kinetic energy and therefore an inelastic collision. Now, there are two types of inelastic collisions. There are the normal inelastic collisions and there are the perfectly inelastic collisions. The normal inelastic collisions are the ones that I just explained. However, their difference with the perfectly inelastic is that while in perfectly inelastic, the objects stick together after the collision, in normal inelastic collisions, what happens is that the objects after colliding, there's a force that pushes them back. So like, let's say if in an inelastic collision, a normal one, if two balls were to collide, they would both bounce back, and that would be an inelastic collision, and there would be a loss of kinetic energy. However, if those two balls hit and stick together, there will be a perfectly inelastic collision. Do you understand?
Yeah.
Okay. So I have some examples here of inelastic and elastic collisions. I'll share the screen with you guys real quick. Example of an elastic collision will be the collision between two billiard balls. So there's two cases in here. There's one case where the first object is moving and the second object is at rest. And then what happens in that elastic collision is that object number one, after hitting, is going to stop, and object number two, which was at rest, is going to start moving, and therefore the energy and the momentum is conserved. Now, the other example would be when two balls are moving in opposite ways, and when they collide, they both stop so that the momentum and the energy are conserved, right? An example of a perfectly inelastic collision will be two football players after they hit each other. So you have one football player, and he's hit by this other football player, which would be object one and object two. And after they hit, they stick together. And that's why it's called a perfectly inelastic collision. Now, there are two important formulas that you're going to use to solve the problems that we're going to do in a second. And those are the law of conservation of momentum and the law of conservation of kinetic energy. The law of conservation of momentum is this one on the top right here that says m1v1 plus m2v2 equals m1v1 plus m2v2. And that basically means that the mass and the velocity of both objects initially are the same as the mass and the velocity of both objects at the end. So their momentum is going to be the same before and after the collision. Now, in the law of conservation of kinetic energy that I'm going to show you guys in a second, this one that says 1/2 m1v1 to the second plus 1/2 m2v2 to the second equals 1/2 m1v1 to the second plus 1/2 m2v2 to the second basically explains the same thing. The kinetic energy before and after the collision needs to be the same. So the values of the mass and the initial velocity of both objects should be the same, and mass and final velocity of both objects should be the same. Now let's move on to the exercise. I want you guys to open the book on page 211, and I'll have Patricia read problem 3 for me, and I'm going to copy it down on the whiteboard.
A 4.2 kilogram bowling ball, sliding to the right at 8.2 meters per second, has an elastic head-on collision with another 4.2 kilogram bowling ball initially at rest.
Okay, so let's copy down the information at first. So we have mass 1, which will be
4.0.
okay, 4. We have V1, which would be
8 meters per second.
We have mass 2, which would be 4. And we have V2. Remember, these two are initial, right? What would that be?
0.
Okay, because the object is at rest. Keep going.
The first ball stops after the collision. Find the velocity of the second ball after the collision. Verify your answer by calculating the total kinetic energy before and after the collision.
So basically, they're asking us for the final velocity of object number 2, right? So what we're going to do, I need you guys to take notes of these values right here because I'm going to erase everything to the problem. So what we're going to do first is that we're going to write down our formula, that is the law of conservation of momentum. That formula basically says that M1 V1 V2 equals M1 V1 plus M2 V2. And we're going to take into consideration that both these velocities on the left are initial and both these velocities on the right are final. And so the thing that we're looking for here is V2, Vf2, so this one right here. So what we're going to do is that we're going to move everything that is not that to the other side. First of all, we're going to start with the M1 V1 on the right, that is adding. If you're passing it to the other side, you got to subtract. There you go. There's the step. And now you're going to have M2 V2. However, you still need to separate the V2 from the M2. So what you're going to do is that you're going to have to move that to the other side. And the way you're going to do that is, since it's multiplying, you're going to divide on the other side. So you're going to divide everything by M2. And now you have your variable right there alone on the right or on the left or whatever you want to draw it. Okay, that's our formula. Everyone got that? Now, all we need to do here is that we need to substitute this into our real values. So mass 1 will be 4. V1 initial would be 8 plus M2, which would be also 4. V2 initial would be 0. And then minus the M1, which will also be 4, times the velocity initial of M1, which would be 8. 8 right here. And all of this is going to be over the M2, which is 4, right? Okay, could any of you guys tell me what this will be? 4 times 8 plus 4 times 0 minus 4 times 8, all over 4.
It would be 8 meters per second.
Correct. So the final answer will be that the velocity final of the object 2 would be 8 meters per second. And now they want us to use the kinetic energy law of conservation of kinetic energy basically to prove that idea. So what we're going to do is that very quickly we're going to draw the law of conservation of kinetic energy. Again, taking into consideration that the values on the left are initial and the values on the right are final. And of course, mass doesn't count because mass will always be the same no matter what. Okay, so after we get our formula, what we want to do is that we want to substitute in the values. So we're going to have 1/2 M1, which is 4, times V1, which is 8, plus 1/2 M2, which is also 4, times V2, which is 0, and both of these are to the second, equals M1, which would be 4. This would also be 8. And then this one. I'm sorry. The final velocity here would be 0, right? Because the object was initially moving, so after it hits, it has to stop. So the final velocity for object 1 will be 0. And then at less here, we're going to have 4 times 8. And as you can see, basically what we have on the left is the same thing that we have on the right. So if we end up calculating all this, it's going to be 128 equals 128. And that basically proves the idea that the kinetic energy was conserved during the collision, and therefore that is an inelastic collision. Do you guys have any questions?
No.
So now that we finished number 3, let's move on to problem number 4 on page 211. Patricia, could you please read it for me?
A 25 kilogram bumper car moving to the right at 5 meters per second overtakes and collides elastically with a 35 kilogram bumper car moving to the right. After the collision, the 25 kilogram bumper car slows to 1.50 meters per second to the right, and the 35 kilogram car moves at 4.50 meters per second to the right. Find the velocity of the 35 kilogram bumper car before the collision. And verify your answer by calculating the total kinetic energy before and after the collision.
Great. So can someone please tell me all the information given in the problem so I can copy here for everyone to see?
Yeah. Mass 1
Okay.
is 25 kilograms.
Okay.
V1 initial, velocity 1 initial is 5 meters per second.
Okay.
Mass 2 is 35 kilograms.
Mm-hmm.
Velocity 2 final is 1.50 meters per second.
1.50 or 15?
1.50. I'm sorry, that's velocity 1 final.
Oh, velocity 1. Okay, so this is 1.
And velocity 2 final is 4.50 meters per second.
4.50 meters per second. Okay, so velocity 2 final. Okay, and so I suppose you're searching for the final velocity for, the initial velocity for 2, right?
Yes.
Okay. So yeah, I'll give you guys some minutes to do this problem, and then we'll come back to look at it.
Ready, mister?
Good job. Okay, so now let's solve it all together. You guys have the information written, right?
Yes.
Okay, so now is there anyone that wants to do this problem, or do you want the 3 of us to do it together? You guys just tell me what to do.
Can I do part A?
Sure.
So in part A, we're looking for V2I.
Okay. Maybe I'll just write for you instead. It's easier.
Please, it's not writing.
Okay, sure. So you need to say, I'll do it, but you have to write it for me. Can you write it for me, please? You just need to say that.
Okay.
Go ahead.
I'll do it, but may you write it for me?
Okay, I got it.
Okay,
tell me what
so
to do.
in part A of problem 4, we're looking for V2I. So we're going to use the momentum formula, and in order to get V2I, we need to clear the formula. So the first step is to move M1V1I to the other side, and we do that by subtracting.
I'm sorry, can you repeat that step?
So we get M1V1 initial and we move it to the other side by subtracting it.
Okay. There you go.
Now we take that M2 and move it to the other side by dividing.
Perfect.
Now we just input all of our given information and V2I should be 2 meters per second.
Okay, we got question A. Now let's go on to question B. But please, if you want, you can do that one too.
Is that one just like inputting all the information into the kinetic energy
Correct.
formula?
Yes.
Can I just say that? So for this one, can I say that?
I mean, I guess.
Okay.
So let's go again. Hold on. Yeah, go ahead.
So for part B of question 4, we have to calculate total kinetic energy before and after the collision, and we do that by using the momentum and kinetic energy formula.
There you go. What do you do next?
So it's pretty straightforward after that. We just input all of the given information, and the result should be 382.5 joules before and after.
Good job. Yeah, that's the answer. Okay, so here you go. The kinetic energy was conserved, and we found the initial velocity for object 2. That's what the problem was asking us. And because the energy was conserved, we can see that it's an elastic collision. Good job, guys. And so basically, as a recap for today, we basically learned what elastic collisions are, what inelastic collisions are, what are the two types of inelastic collision. We also learned some real-life examples of both types of collisions. We saw the law of conservation of momentum, the law of conservation of kinetic energy, and how to solve problems that involve elastic collisions. So that's it for today, class. Thank you for joining, and I'll see you next class. Stay safe.
Thank you, mister. Bye.